Hello students, how are you? So today we will do next part of this chapter number 6, class 10th, triangles. And we will do what's Thales theorem, its converse. We can prove these by theorems and these by activity also. Till yesterday what I told you types of triangles. I told you definition of congruence triangle or congruence figure. Congruency rule, you can say what two figures are said to be congruent if their shape and size are same. And two figures are said to be similar if their shape is same but size may or may not same. Understood? Yesterday I told you three definitions of similarity. One definition, what's one definition? First definition is this: two figures are said to be similar if their shape is same but size may be different. Then what I told you two figures are said to be similar if their corresponding angle are equal and corresponding side are in the same ratio. Understood till here? So now we can start next part when proof of this definition given of similarity. What if corresponding angle are equal and corresponding side are in the same ratio? After that, one mathematician named Thales said that, what said? If corresponding angle are equal, it's meaning if you are talking about triangle, so they become equiangular. What type of figure is become equiangular? Then definitely their side are in the same ratio. What's its meaning? Its meaning is this: if we can prove, what we can prove? If the corresponding angle are equal of two figures, then they automatically become what? Similar. So we can start of topic of today. So what's this given? Similarity of triangles. So in this chapter we will read about what? Similarity of triangles. Understood? I already told you, in your book also given similarity meaning what? Shapes same but size may be different. So what's saying, what can you say about the similarity of two triangles? So we know this triangle is also a polygon. Triangle is also a polygon. So you may recall that triangle is also a polygon. So we can state that the some condition for the similarity of two triangles, that already I told you. If you are having two polygons, so similarity rule saying first is what? Their side must be same. That's coming in the shape. And later on say that corresponding angle are equal and corresponding side are in the same ratio. So saying like this, both condition telling two triangle are similar. This is also a polygon, triangle is also a polygon. So definitely satisfying the condition which are given in polygon. What saying? Their corresponding angle are equal. Already I told you. Two triangle are similar if their corresponding angle are equal and their corresponding side are in the same ratio. Corresponding side I can tell you easily. Once again I can repeat. If we are having what we are having, we are having two triangles. One triangle is this. This is the triangle. What's its name? ABC. Another triangle. This is DEF. What triangle? DEF. And this given triangle ABC is similar to triangle DEF. Its meaning is what? What's correspondence? Its meaning is this: angle, which angle? ABC, this angle, is equal to angle DEF. Try to understand, this is important. How can I write ABC I have written, D angle coming, DEF written? No gap in it. Then I can write A convert into BCA, then here what? EFD. BCA, EFD. Correspondence saying like this. So it's meaning this B equal to this, then what? C equal to this. Yes or no? And then here CAB, CAB, then here also FDE, FDE. This is saying correspondence. What said? Correspondence. So angle are corresponding angle are equal, and corresponding sides, side meaning first two parts taking AB by DE is equal to last two part BC by EF. First and last AC by DF. Understood? And one point kept in your mind, if I can write triangle ABC is similar to triangle DEF, its meaning is not that triangle ABC is similar to triangle EFD. It's not 100% sure. Understood or not? If these are similar, these may or may not be similar. This I want to tell. Correspondence must be like this. In congruent triangle, we are using CPCT, corresponding part of the congruent triangle. And this theorem, which theorem? Thales theorem, so much important. So much important for this chapter. So I told you we are talking about this. So note that their corresponding sides, which I said to you, I told you what's the meaning of corresponding side are in the same ratio or proportion. Both same meaning. Note that if corresponding angle of two triangles are equal, then they are known as equiangular triangles. So it's meaning if corresponding angle of two triangles are equal, definitely they become equiangular. Equiangular, how can? If you have taken this triangle ABC, this angle 60, this 80, this 40, and another triangle is this DEF. So its angle also this 80, this is 60, this is 40. So both are equiangular. We can say both are become equiangular here written. So we know that equiangular triangles. If famous Greek mathematician Thales give the important truth relating to two equiangular triangles, which as follow. The ratio of the any two corresponding side in the two equilateral triangle is always same. What saying? He said, and he given proof also of that. This later on we can prove that theorems. What he said? He said that if two triangles are equiangular, understood? Any two triangles, if they are equiangular, then definitely their corresponding side are in the same ratio. Its meaning what? Its meaning is this: if we can take two triangles and we can prove its corresponding angle are equal, then its corresponding side automatically become in the same ratio. So it's meaning if we can prove corresponding angle are equal of two triangles, then directly we can say these are what? Similar. So it's meaning Thales what's done? Reduce our work. If we can prove this only one point, this one, then directly we can say by using what? Thales theorem. So first we will do activity related to Thales theorem, then we can try to understand that theorem. Not so much difficult, but very important. Not for exam point of view, but if you want to solve what this chapter, if you want to solve this chapter easily, and if you want to understand this chapter easily. So what's saying? Same, it is believed that he had used result called basic proportionality theorem. So this is what? That's believed. He used what? Basic proportionality theorem. That theorem you can say BPT, basic proportionality theorems, Thales theorem. So what we can say? Known as Thales theorem for the same. To understand the basic proportionality theorem, let us perform the following activity. So we will do one activity, then we will write the proof of that theorem, and then so to understand the basic proportionality theorem, let us perform the following activity. One activity is given here. One activity is given to you. What's activity? Look here. This activity. Activity, draw any angle. So we can take what we can take. We can take what we can take. We can take ray. This is a ray. This is a ray. Ray meaning, ray is what you can say, having starting point but not ending point. Ray is like this. This is a ray. So this is its starting point and we don't know its ending point. So we have taken a ray. Which ray? AX. But we have taken ray and make an angle XAY. We are making here acute angle, this angle. And draw this. We are making angle, which angle? XAY. XAY. Understood? This activity, how can you start? You can take a ray. Here its name is AX. There what it may be named according to you. Then making an acute angle. So like this we have taken. What we have taken here I have taken this. This point is A and this point is X I have taken. And making here what? Acute angle. Acute angle, you understand? Less than 90-degree angle. So making this acute angle like this. Here is a point, what's Y? Making angle, what's X, A, Y? This angle making. Here also, we have taken this ray. Or you can say, I have taken this ray. Making this angle, then become. So I have made this angle X, A, Y. In your, here, draw any angle X, A, Y on its one arm, AX. One arm, AX, this is the arm. Mark points, say 5 points. So we have taken 5 points of equal length. 1 point we have taken here. 1 point we have taken here. What's this point we have taken? This taken. 3, 4, 5. Such that meaning, how can we have taken like this? AP equal to PQ equal to QD equal to DR equal to RP. So here you can take, what you can take here also you can take this point taken, name of this point, what's name according to P, name of this point Q, this is D, what's this R, and what's this P. What we have taken? B point we have taken. So here you can take. So we are saying such that this AP equal to PQ equal to QD, DR equal to RD. Already I said AP equal to PQ equal to QD equal to DR equal to RP. Understood? Now through B draw any line. So this we can take scale and draw any line. What we can draw? Any line. We draw these lines. Any line with the help of scale which cutting the ray AY at point C. Where? C. So here we can draw like this, cutting this point at C. Yes or no? Now through B draw any line intersecting arm AY at C. See in the figure. Also through the point D. So we measure this angle. Same angle making here and draw this, which intersect AY at point E. This angle equal to this angle and this angle equal to this angle. Third angle automatically become equal, common in between them. Understood? Its meaning this is parallel to this, we can say. So here in your book written, now through B draw any line intersecting AY at C, and also through the point D draw a line parallel to BC which intersect AC at AC. This line, or we can say AY at E. So this. So this we can draw. This angle we can measure. Same angle making here. Making this and like this, draw like this. And cutting this point at what point? E. So ED is parallel to BC. ED is parallel to BC meaning this angle, our construction and this angle equal to this angle. So this third angle automatically become equal. In which triangle? In triangle AED and triangle what's? ACB. ACB. Or you can say AED, ACB. Got? Yes or no? So what you can say about AD? What you can say AD by DB? AD by DB. AD by DB. So it's meaning 1 unit, 2 unit, 3 units. So it's meaning AD equal to 3 units. And after this 1 unit, 2 units. Understood this? Understood this or not? Got or not? So understood this. Measure, then we can measure this AE by EC. AE by AC, so definitely this equal to 3 by 2. If you can measure it with the help of measuring scale, so definitely this ratio also 3 by 2. If it is 3 centimeter, this is 2 centimeter, this is 6 centimeter, this is 4 centimeter, this is 9 centimeter, this is 6 centimeter. Understood this? So measure AC. What about this? This is equal to this. Thus you can say that triangle ABC, D parallel to BC. So in triangle this, what happened this? So understand, try to understand what I want to tell. So what you can say? So here in this triangle already I told in triangle AED and triangle ACD, DE is parallel to BC. This is our construction. Then what's coming? AD by DB equal to AE by EC, each equal to 3 by 2. If this is parallel to this, it's meaning this angle equal to this angle equal to this, and third angle also automatically become equal. So satisfying first condition, satisfying second condition also. Understood? Thus you can see that triangle ABC, D is parallel to BC and AD by DB equal to A by C. Is this coincidence? So written, is this a coincidence? No, it's not a coincidence. You can take any other triangle, any other ray, and you can make like this. Then definitely coming equal. Then definitely coming equal. So no, it is due to the following theorem. So this is possible by this BPT theorem. Sometime in exam coming, state and prove BPT, basic proportionality theorems. Sometimes saying state and prove Thales theorem. Sometimes statement given and saying you can prove it. So we will prove what we will prove? BPT. What we will prove? BPT. BPT meaning basic proportionality theorem. What's this theorem saying? If a line drawn parallel to one side of a triangle. So here this DE, you can look here. Here DE is parallel to BC. So that's why saying if a line is drawn, which line? This DE, parallel to the one side of a triangle, intersect the other two sides. in two different points. So first point is here, this D intersecting at this point, another point is this. So DE is parallel to BC. Theorem. BPT meaning basic proportionality theorems, or we can say Thales theorems. Understood? What's saying this? If a line drawn parallel to one side of a triangle, so first try to understand this part till here. If a line is drawn, line meaning line segment. So we are having a triangle. This triangle we can take. This is a triangle. What's its name? What it may be. According to this, what's its name? ABC. This is a triangle. And a line is drawn parallel to the one side of a triangle. So it's meaning we can draw like this also, which is parallel to BC. We can draw like this also, which is parallel to SC. We can draw parallel like this also, which is parallel to AB also. It's not compulsory you have to take like this. So a line segment, if a line is drawn parallel to one side of a triangle, we can draw a line segment which intersect the other two sides. So here this line segment or line is parallel to this, and this line segment intersecting other two sides. Which side? AB and AC at point D and at point E respectively. So saying if a line drawn parallel to the one side of a triangle intersect the other two sides in different point, the other two sides divide in the same ratio. It's meaning if you can draw a line this like this, DE is parallel to BC, then AD by DB equal to AE by EC. This is Thales theorem. Understood? Or in other way, triangle ADE and triangle ABC both are equiangular. Both are equiangular. Why? This angle equal to this angle equal to this angle, and this is common. Understood? So it's meaning Thales what said? If you can prove all three corresponding angle of one triangle is equal to the corresponding angle of another triangle, then two triangles are similar. So that proof of that. Understood? So we have to prove. So it's meaning given what's given in triangle ABC. We are given what? Triangle ABC, in which line parallel to BC. Which line? In which a line? Which line? DE. A line, which line? DE is parallel to BC, which intersect AB at D and AC at E. Understood this? And what we need to prove? We have to prove AD by DB equal to AE by AC. So this also I want to tell, if theorem given to you, so first what you can write? First you have to write given, then what you have to prove, then if any construction you need, and then proof. So these are 1.2.3.4 steps. Must need to prove a theorem. Given, which is given in the theorem, to prove which result of the theorem, which want in theorem to prove, and proof, you know how can you prove it. Construction, any construction you need, like this in triangle we need some construction. So construction also we can write join B, join what? B. Join this B and E. So like this. And C with D. Understood? Join B with E and C with D and draw perpendicular with what's draw perpendicular like this. DM. Draw DM perpendicular on AC and EN perpendicular on AP. EN perpendicular on AP. Perpendicular meaning 90-degree angle, this also 90-degree angle, this also 90 degree. Understood? Again I can repeat. What's theorem? If a line segment drawn parallel to the one side of a triangle, here D is parallel to BC, then which intersect the other two sides at different point, then side are in the same ratio. It's meaning D is parallel to BC here, and we have to prove AD by DB equal to AE by AC. This we have to prove. Here also written. So given what need to prove, here written. This we have to prove already, I told you. Then this is saying construction. Let us join BE, I told you, and CD, C with D, and then draw DM perpendicular on AC, and EN perpendicular on AP. Only one point in this theorem, if you can understand that point, easily able to show. So what's the proof of this? What? So in class 9th, you know, area of triangle AD is denoted by like this. So what we can do, we can find out area with the help of that. We know area of triangle is what? 1/2 base into height. That's why you drawn perpendicular on it. So what you can take? We can take triangle ADE. Area of triangle ADE. You know what's the area of triangle? 1/2 base into height. 1/2 written. AD is what here? Base. And what is this? EN. EN is perpendicular. So this is the formula. So AD by AD into EN. This is, you have taken, understood this? Yes or no? We need what we need? AD. This AD we need. That's why we have taken triangle ADE. In downside, what we need? DB. So DB is here. In which triangle? This triangle. In which triangle? This triangle. This triangle. Just wait. This triangle DBE. We can find out area of this triangle also. Same formula. What's it? Same formula. 1/2 base into height. 1/2 base into height. But what's your base here? Base is definitely DB. What's it? Base is definitely DB. So we have taken 1/2 DB. And what's perpendicular? What? EN. So here point is this, why we have taken EN is perpendicular of this, which is lying outside of it. Actually this triangle is like this. Actually this triangle is like this. Obtuse angle triangle, this angle is more than 90 degree. What's it? And it's what point this? This point E, this point, what you can say? Which point is this? E, this is B, which is what we can say? This is D and this is B. This I have taken. Or if you want to take according to this, you want to take, I can tell like that also. This triangle is like this. Put it here. So this is D point, this is E point, and this is P point. And this going like this. What's it? EN is perpendicular to AB. So if obtuse angle triangle and saying find out its heights, so height is always like this. this perpendicular. That's why we have taken EN as perpendicular here. Understood? So this is the main point in it. Remaining point you know all of these. So find out the area of triangle. Which triangle? This triangle DBE. Because we need AD needs, then DB need. Next again AE need, EC need. So first we will take this. So 1/2 base DB, and what's its height? This EN. Why its height is EN? That I told you. Or other point, what you can say? EN is perpendicular on DB, on AB. So EN definitely perpendicular on part of AB, which is DB. Perpendicular meaning shortest distance. Understood? So I have what I have written? EN. What I have written? EN. So this you can say number 1. This you can say number 2. Understood? Now what we need? AE. Where AE? In this triangle. ADE here. So again we will take this triangle. Now taking base what? AE. And this is what? Perpendicular DN. So again we have taken area of triangle ADE 1/2 A into DN. Understood? And what we need now? This EC need. EC is this. Coming in which triangle? DEC you can say, ECD you can say, CDE you can say. So we are taking DEC in this triangle. Again 1/2 base is what? EC. Again this also become like this triangle, like this and like this. So join like this. Understood? And perpendicular height means we can change it and like this. This is the perpendicular height. That's why we have taken DM. So what's written here? What's written? DM. So what we can say? Now, what you can say? This is third. This one is third you can say. And this one is what you can say? Fourth. Then what's dividing equation first by second? If you can divide this equation, area this coming here by this one, this complete coming here, this complete coming here. 1/2 both cancel each other. EN cancel. So what's left? AD by BB. Yes or no? Then divide equation number 3 by equation number 4. So what's coming? Equation number, area of triangle ADE divided by the area of triangle DEC. So what's 1/2 AE into DM. And what's its 1/2 EC into DM. Again this cancel, which common? This cancel, what's left? AE by EC. AE by EC. So this came. What left? How can we prove AD by DB is equal to AE by EC? Look here. What's numerator here? Area of triangle ADD. Here look. What's the numerator here? Area of triangle AD. It's meaning numerator of both are same. Numerator this and this same. Then what left? Denominator. And if we can apply any method by which we can prove area of this triangle and this triangle are equal, then what? Then both become equal. Numerator same, denominator also become same. So it's been satisfying that property. If this become equal, so this also become equal. Understood? So we will try to prove this area and this area are equal. So you look one time. These two triangle, which triangle? First triangle is BDE and triangle, what triangle? This one DEC. Lying on the same base. lying on the same base and between the same parallels. D is parallel to BC. Which one is their base? This is the base. D is their base of both triangle. Which triangle? BDE and DEC. What's the base? DE. What's their base? DE. And this parallel to this. So this is the theorem. Both triangle written. Note that triangle BDE and DC are on the same base and DE and between the same parallel. And both triangle lying between the same parallel lines because DE is parallel to BC. If satisfying this condition, then area of both triangle are definitely equal. This is a theorem in 9th class. If you need, we will revise that also. So what's coming? This coming. So this area of these both triangle are become equal. Numerator already equal. Denominator by this theorem equal. So what you can say by first, second and 3? So we can say its meaning. It's before this you can write area of triangle ADE by area of triangle BDE is equal to what's area of triangle ADE by what? Area of triangle, which triangle given? DEC. Which triangle given? DEC. But what's this? After solution means this. So I have written what I have written. It's meaning AD by DE equal to, and what's its area? Its area is like this. This given A by EC. So this become A by EC. Hence result you can see. Hence result. So simple or not beta, but so much important. So much simple, but so much important. Understood? What's again I can repeat, try to understand its statement. If a line segment drawn to the parallel sides, parallel to the one side of a triangle, which intersect the other two sides at different points, then side are in the same ratio. Understood? Or we can say if two triangle are equiangular, then definitely their corresponding side are in the same ratio. This proof given by Thales, so saying it's Thales theorem, saying it's BPT also. What's BPT also? Then saying, is its converse true? Is its converse true? So what's its converse? Try to understand. Theorem is this. This is the theorem. BE, BC. Here is A. Understood? What saying? What you have to prove in this BPT? AD by DB equal to AE by EC. So converse means this. Given become to prove become given. So what's given? What's to prove here? This. So meaning this is given in that theorem, next theorem, converse of it. And what we have to prove? This you have to prove DE is parallel to BC or not. This is saying the converse of the BPT. Converse of BPT. One activity given, this also possible. One activity given, and after that proof of that theorem given. So activity we can do, then we can solve that theorem. But that converse is so much easy as compared to it. In it also one point that I told you, that try to understand, then no problem. So come on next, like this. So activity number 3, this given. This is the telling what's converse also true. Converse of whose? BPT. It may be possible question coming in your exam like this, state and prove converse of BPT. Converse of BPT. What's the converse of BPT? That I can tell you. But what's that? Easily you can say if side are in the same ratio, then that line is parallel to the third line. So it's meaning this. So draw angle XAY, that already I told you. Draw an angle XAY. We have taken this ray first. This ray, AX ray we have taken. And ray already I told you having starting point. This is a starting point but not ending point. It's meaning this moving in this direction, continuous. Till where? Till infinity. Making this angle, what's angle? Alpha. And this is like this. This point has taken XAY angle. So that's why I draw an angle XAY. And on ray AX marks point B1, this is first point, B2, B3, B4, B5. Such that AB1 equal to B1, B2 equal to B2, B3 equal to B3, B4 equal to B4, B. Last one B saying. That's written here also. Similarly, on ray AX marks point C1, C2, C3. So this is point C1, C2, C3, C4, C. Such that AC1 equal to C1, C2 equal to C2, C3 equal to C3, C4 equal to C4, C. Which is written here. Like this. Then join B1, C1. So we will join like this B1, C1. What join? B1, C1 and B with C. Joining like this. Which is given in the figure. Note that AB1, then if you can find out AB1 by AB. AB1 meaning 1 point, 1 scale we have taken. It's meaning this is equal to 1. What's AB? 1, 2, 3, 4, and what is this? 1, AB1 we have taken, or what we have taken? B1B we have taken. So what we have taken? AB1 and B1B. This is 1, and what's we have taken? AB1 by B1B. Sorry, I have written wrong. You can take like this also. Then what's coming? 5 coming. Here 4 given, different point taken, and if you want to take according to that, then you can write like this. Then you can write like that. What's coming? B1, B. So here coming 4. B1 start from 1, 2, 3, 4. Understood? And what is AC1? AC1 equal to 1 by C1C. Again, this is equal to 1 by 4. This is written here. You can also see that B1, C1 and BC are parallel to each other. And this is parallel to this. So what he want to said, if side are in same ratio, then these are parallel. And if these are parallel, then side are in the same ratio. Understood? BPT saying, if these are parallel, side in same ratio. Converse saying, if side are in same ratio, these are similar. Same process here using. Similarly, by joining B2, C2. So if we can join, we cannot join this, we can join this. Then what's become? AB2 by B2B. AB2, 1 step, 2 steps. So what's written? 2. And what's 1, 2, 3. So what's coming? 3 coming. So written B2, C2 parallel to this written. So from first, second, third, fourth, it can be observed that if a line divides 2 sides of a triangle in the same ratio, then the line is parallel to the third side. So this becomes converse of BPT. So what's converse of BPT? Converse of BPT is this. What's if a line divides any 2 sides of a triangle in the same ratio, then the line is parallel to the third side. What's saying? What's its meaning? If a line segment divide the 2 sides in the same ratio, then that line segment definitely parallel to the third side. This is saying converse of BPT. So what's saying? If a line divide any 2 sides of a triangle, in the same ratio. So we have taken what we have taken, this triangle we have taken, this triangle. What's the name of this triangle? ABC. What's the name of this triangle? ABC. This is point is A, this is B, and this is C, and this is a line. This is a line, line DE, which intersecting AB at D, AB at D, and AC at E. So, if a line divide any two sides, so we are having a triangle. What's triangle ABD, and this DE divide this side in the same ratio, then DE is parallel to BC. This you have to prove. So first what we can do? We can prove this by first what you can write given. What's given? This is given. Given is this. If not understanding, I have written here. AD by DB. AD by DB equal to AE by EC. AE by EC. To prove is this. DE is parallel to BC. This is to prove. So I told you, converse meaning given become to prove become given. So we can prove this theorem by contradiction. This theorem by contradiction. What's contradiction? We can say this line divide these side in the same ratio, but this is not parallel to BC. But this is not parallel to BC. So, if it is not parallel to BC, we know we are able to find, we draw a line either from here or from here. So, we draw a line like this, DE dash. We draw a line which DE dash, which is parallel to BC, which is parallel to BC. If it is parallel to, then what we can say? If it is parallel to, so what's its meaning? If it is parallel by BPT, AD by DB, which is already written here, AD by DB is equal to AE dash by E dash C. Yes or no? We can write this by BPT. Here, right. Basic proportionality theorem. Definitely better use of this theorem in exam. Without use of this theorem, not possible to cover chapter number 6. So by BPT I have written, what is this? AE by EC, AE by EC, AD by AE by EC. Then what you can say? What you can say? But this given, what's given? This AD by DB is equal to AE by EC. AE by EC. What's AE by EC? This is saying first number. This is saying second number. Watch. Look one time left hand side. AD by DB. AD by DB. So left hand side are equal. It's meaning right hand side also equal. Understood? So it's meaning AE by EC equal to AE dash by E dash C. AE dash by E dash C. Is it possible? AE dash is this, A is this. Is it possible? Not possible. This is possible only when E and E dash are same point. Understood? That you have right. Otherwise, what you can do? You can add one in it. Add one in it, which is given in this theorem. So what's this? AE by EC plus 1 by 1 and AE dash plus E dash C plus 1 by 1. If you are adding same quantity both in both sides, left and right, no effect on it. So what's your LCM? LCM is this EC. What's AE plus EC? AE plus EC equal to what's your LCM? E dash C. What's it's become? AE dash plus E dash C. And what about AE by EC? AE by EC, what's become? This become, this from here, right? AC by EC. And this what's become? AE dash by E dash C. This also become AC by E dash C. Both are equal. Both are equal. Numerator also equal. So definitely their denominator also equal. So it's meaning therefore EC by equal to E dash C. Otherwise what you can say is, you can say this not possible. This possible only in one condition, when E and E dash are same point. Otherwise you can add one in it. These both are equal. Its numerator also equal, so denominator also equal. Then they become equal. So this is the proof of what? Converse of Thales theorem you can say, BPT theorem you can say. Both theorems so much important. If you can understand this theorem, it's meaning you can understand this chapter. Easily able to show. So you can revise it. If anywhere problem, then again I can tell. I told you there is a 1 point in BPT. If you can understand that, why we have taken this perpendicular, then no problem, I think. So I told you, if not understand, again I can repeat. So you can revise these, and this is the base of this chapter, these two theorems, BPT. So after these theorem, what we can say? We can say two triangles are congruent if their corresponding angle are equal. This is sufficient. If corresponding angle are equal, definitely their corresponding side in the same ratio after the proof of these theorems. And proof of these theorems given by Thales. That's why saying these Thales theorem also, BPT theorem also, basic proportionality theorem. So this is the end of this lecture for today. Thank you. Tomorrow again we can start, tomorrow or after day after tomorrow, in next working day, we will do next part of it. We can start with the example, so you can revise it. According to me, this chapter is so much easy if you can understand.